Hello everyone, welcome to MEMONEET. I'm Aprajita, your chemistry SMA. Today we are going to discuss the solutions for full length test 10. So let's start with our question number 51, which is the first question of chemistry. So it says for the following cell with hydrogen electrodes at two different pressures P1 and P2, the cell reaction is given to us. We need to tell what will be the EMF in this case. So let's see the left hand side reaction. So here hydrogen is getting oxidized, so 2H plus ions and 2 electrons are lost, so this reaction takes place at the anode, whereas the right hand side half cell reaction, here 2H plus gains electron to become hydrogen, so this takes place as cathode because this is reduction. Now if we combine these two reactions, so these two things will cancel out, we will be left with H2 gas at P1 to H2 gas at P2. Now we need to find the E cell, so the formula for E cell in this case would be E naught cell minus nRT, or you can say RT upon NF log K. RT upon NF log K. So in this case K would be, so we know that K is like the species that are present at the product divided by the reactant. So what happens in this case, there is pressure given to us, so we will take the pressure at the product side P2 divided by the pressure at the reactant side P1, so K is P2 upon P1. Now if I talk about E naught cell, now E naught cell for hydrogen electron is 0 because hydrogen is taken as the standard, so it will be 0. So we will be left with minus RT upon NF log K. Now N in this case is 2. Right, because there are 2 electrons involved, so the value of N is 2. So it will be minus RT upon 2F log P2 upon P1. So if we need to remove this minus sign, we will be reversing the log. So it will be RT upon 2F log P1 upon P2. So let's see, the answer is RT upon 2F log P1 upon P2, which is your option number 2. So that is going to be our answer. Now question number 52, which of these elements exhibit the highest covalent character? So we know that the covalent character of these compounds will be determined by the Fijan's rule. So according to Fijan's rule, the main thing is that smaller the size of the cation, and of course greater charge of the cation and large size of the anion. Greater charge on the cation and large size of anion. All these things will favor the covalent character. They will increase the covalent character in this case. Now here we can see the anion is chloride in all the cases. The cations are Na plus, Mg2 plus, Al3 plus and Si4 plus. Now we know that as the charge increases, the size becomes less and less because there will be more nuclear charge. Okay, so here Si4 plus will be having the smallest size. Smallest size is there, greatest charge is there, plus 4. So it means its charge density is more and it is having more polarizing power. So it will polarize the anion to the maximum extent, and that is why the SiCl4 will be having the highest covalent character. So that is the answer. Question number 53. Identify the strongest nucleophile among the following. Okay. So the nucleophile in this case, the strongest nucleophile will be the one in which the lone pair of electrons are readily available for bonding. So that will be acting as a good nucleophile. So if we see here in C6H5OH, the lone pair on oxygen, they will be in resonance with the benzene ring. If I compare the CH3Cl, CH3OH and CH3NH2. Now the CH3NH2 will be the strongest nucleophile because there will be lone pair of electron present on the nitrogen which it can readily donate. So as compared to other nucleophiles, it will be having the highest nucleophilicity. So the answer is option number A. Moving ahead to the next question. Question number 54. Now we need to find the density of carbon dioxide gas at 127 degrees Celsius temperature and 2 atmospheric pressure. Now how we are going to find out the density of the gas? So first of all, please convert this temperature to Kelvin. So it will be like 400 Kelvin. Now we know for gas, if we apply the gas equation, so here we are considering 1 mole, so PV is equal to RT. Now we need to find the density. So in this case, we can say that volume will be mass upon density. Here we are considering mass upon density equals RT. So from here, the value of density will be PM upon RT. So this formula we will be applying to find the density. So pressure is given to, now molar, M is the molar mass of the gas, right? For carbon dioxide, the molar mass will be 44 gram per mole. Now the value of R we will be taking 0.0821 and temperature is 400. So when we solve it, it comes out to be 2.68 gram per liter. So that is the answer. Here we have applied the gas equation for calculating the density. Now 55th question is NH3 and NF3 both have pyramidal shapes with the lone pair of electrons on nitrogen atom. Then why does the dipole moment of ammonia, that is NH3, is greater than NF3? So we know, yes, fluorine is more electronegative than nitrogen atom. So according to that, NF3 must be having a higher dipole moment, because dipole moment is the product of magnitude of charge and the distance between the positive and the negative charge. Now let's see other statements. Now if we see the dipole moment, so in the case of NH3, if we see the direction of the dipole like this, okay, and for lone pair. So yes, in NH3 the orbital dipole is in the direction as same as the NH bonds. Like you can see, they are all in the same direction, so the resultant dipole moment will add up. But in NF3, since fluorine is electronegative, so the dipole moment will be in this direction like this, and for lone pair in this direction. So in NF3 the orbital dipole is in the direction opposite to the resultant dipole. So that is the case here, it would be subtracted. The net effect would be subtracted. If we want to calculate net dipole moment, so it would be subtracted. So that is why here addition is taking place and here subtraction. So NH3 is having more dipole moment than NF3. So yes, all of the above statements are correct. That is the case. Okay, question number 56. 5% weight by volume solution of urea is isotonic with 2% weight by volume solution of non-electrolyte. So we need to find the molar mass of that substance. So students, first of all, isotonic solutions means which have same osmotic pressure. Same osmotic pressure is there, means pi 1 is equal to pi 2. Okay. Now we know that for first one, like it's urea, and the second one is unknown. So pi is equal to CRT, where C is the concentration. And so now in this case, what we can say is that R and T would be constant. So if pi 1 is equal to pi 2, so C1 is equal to C2, which will be the weight of the given substance upon the molecular mass. And here we can say the weight of the second substance divided by its molar mass. So basically in this case we are not considering volume, because here we can say the volume must be same. So we can put the values in this case. So there is a 5% solution of urea, weight by volume. So 5% here we can say that 5 grams is present in 100 ml. So we can take 100 ml as the volume. So in this case the molar mass of urea is 180 and equals, so 100 volume will cancel both sides, so we are not writing it. Now W2, so W2 is 2%, no? So 2%, 2 upon M2, that we have to find out. From here M2 will be coming out to be 24 grams per mole. So this is the molar mass of the second substance, that is 24 grams. So students, next up is question number 57. So here we can see, if the internuclear axis is taken to be z direction, then which of the following orbital does form sigma bond? So we know that if the internuclear axis is in the z direction, so of course the pz orbital, let's see if it is the z direction and it is the internuclear axis. So the z orbital, pz orbital will be forming sigma bond by the head on overlap, okay, like, and but if we have having px or py orbital, so they will be forming pi bonds. They cannot form the sigma bond. So in this case the answer is going to be option number 3, that is pz orbital will form the sigma bond, px and py will be forming pi bonds. Now, which of the following is 2-chloro-3-methyl butene 1? So for that we need to do the numbering in this case. So we'll be starting with this carbon 1, 2, 3. So here we can see there are 3 carbons, but it's but, so that is not the right option at all. Now let's start 1, 2, 3. So in this case also, okay, that's methyl group now. So alright, we will be doing it from the left hand side, because since OH is on the left hand side. So 1, 2, 3, 4, but it's 2, 3 dichloro. There are 2 chloro groups, so this is also not correct. Next up is the third one. So let's start from here. 1, 2, 3 and 4. So again there is 2 methyl, 1 chloro, 2 methyl. So yes, chloro is at the first position. This is also not correct. So let's move at the last one. Okay, last one is 1, 2, 3 and 4. So yes, here we can see it's 2 chloro, then it's 3 methyl. There is a double bond between second and third carbon, so but-2-ene and 1 ol. So there's alcohol at the first carbon. So yes, the correct answer would be option 4. This is the given compound. Next, the energy of an electron of 2py orbital is. So we have to compare the energy of 2py orbital with 2pz, 2px and 2s. So actually we know that the energy of electron depends on n plus l value, like it is in which shell and subshell. So for 2p, the value of n plus l is same, right? So in that case, all the like electrons that are present if in 2px, 2py or 2pz orbital, it is going to be same. So they are known as degenerate orbitals because they will be having same energy. Because the energy will not depend on the m values, it will depend on n and l. So of course it's same as that of 2px and 2py, but of course it will be more than 2s, so that's why it is also not correct. So answer is option 3. Third one. Next, the magnitude of hydrogen bonding depends on physical state of the compound. It is maximum in the solid, liquid or gaseous state. So we know that in the solid state the molecules are closely packed, right? Whatever molecules are there, they are closely packed, so there will be strong interaction between the molecules or atoms, whatever it is. So if the molecules are closely packed, the hydrogen bonding, the like magnitude of hydrogen bonding will also be more, right? Because the molecules, they have less space to move as compared to liquid or gaseous state. So in that case, the hydrogen bonding will be strongest in the solid state because the molecules are closely packed and have less freedom of movement. So answer is option A. Question number 61. Which statement about the given reaction is inaccurate and needs to be corrected? Okay, so in question number 61, we can see that there is propene. Let's draw it here. Let's draw it like this: CH3, CH, double bond CH2, and there is an addition of halogen in the presence of CCl4. So of course there would be an addition product formed. Okay, like X2 will be added along the double bond. But the thing is that what is the mechanism of this reaction? So in this case, let's see, if we are having X, so here will be like induced dipole in X2. So partial plus partial negative charge. So this double bond, it will attach here. So here you can see, and this will go here. So what happens is that a cyclic intermediate is formed. You can see, so I can write X plus here. We are generally taking any halogen. Okay, so yes, it involves a cyclic halonium ion as intermediate. This is our cyclic halonium ion. Now the other X ion, the negative one that we were having here, it will attack from the back side. It will attack from the back side, and this will happen, and we will get a dihaloalkane like this. Addition product is formed. So yes, now you can see that it involves halonium ion as intermediate. This is correct. Carbon ion intermediate, we cannot see any carbon ion intermediate here, so it's wrong. Reaction involves anti-addition. Yes, anti-addition means it's coming from the back side. Okay. And chiral atom, yes, so this one is our chiral atom, is in the product. Chiral atom means which is attached to 4 different groups. So this one is our chiral atom. This is also correct. So we need to find out the incorrect statement. The incorrect statement is second one. So our answer is option 2. Question number 62. Students, 2 electrons occupying the same orbital are distinguished by. So yes, you know, if you are having two electrons which are in the same orbital, let's say it's 2p. So here they will be having same value of it's here we can say that both of them are in 2px. So the value of n is 2, it's same. Okay, the value of L is 1, it's also same, and the value of M is also same. So where the value is differing, it's differing in the spin quantum number, because one will be having a positive spin and the other one will be negative. So the spin quantum number will be plus half or minus half. So they will be having different values of spin quantum number. Other quantum numbers would be same. So answer is option 4. Next is question number 63. The group 13 elements react with halogens to form trihalides. Okay, except, so which one does not form trihalide? So here we are having BCl3, thallium iodide, TLI3, aluminum chloride, and gallium iodide. So students, you must know that elements of group 13, they will react with halogen to form trihalides, except thallium. This compound is not stable. So why it is not stable? Because in thallium, the configuration is like this: 4F14, 5S10, 6S2, 6P. Now the outer shell has 3 electrons, but because of the inert pair effect, poor shielding by 4F and 5D electrons, these 6S electrons, they are not going to participate in the bonding. So that is why the stable oxidation of state of thallium would be TL plus 1, not plus 3. This one won't be possible. It is not stable because of the inert pair effect. 6s electrons are not participating. So that is why TLI3 is a not stable compound. Others would be formed. So answer is option 2. Next up, question number 64. Calculate the amount of carbon dioxide that could be produced when 1 gram atom of carbon is burnt in 0.5 gram molecule of dioxygen. Now 1 gram atom of carbon means 1 mole of carbon, and similarly 0.5 gram molecules of oxygen means 0.5 moles of oxygen gas, like O2. Okay, now we all know that carbon reacts with oxygen to form CO2. Now 1 mole react with 1 mole of oxygen to form 1 mole of CO2. But in this question we are having 0.5 moles of oxygen. So if 0.5 moles of oxygen is there, it means the reaction will not complete. The carbon will not be fully utilized because we require 1 mole of oxygen. So in that case, our oxygen is the limiting reagent. If it is the limiting reagent, the formation of product depends on the amount of oxygen. So here we know that if 1 mole of oxygen is giving out 1 mole of CO2. So 0.5 moles of oxygen will be giving you 0.5 moles of CO2. So in that case, the product will be half mole. Half mole CO2 is formed. So I think this one is clear. Next up, question number 65. Which of the following reaction does not result in the formation of an alkyne? Okay. So here, if the halogen groups are present on two different, like two adjacent carbon atoms, like in these two cases, we call them as vicinal dihalides. So both of them are vicinal dihalides. If it is present on the same carbon, it's geminal dihalide. So students, in this case, what happens is that yes, sodium amide is a strong base, NaNH2. So these vicinal dihalides, they undergo dehalogenation in the presence of NaNH2 to form alkynes. So in this case, there is only one halogen in first and three. So first and three are not going to give us the alkyne, but second and fourth will give you the alkyne because they are vis dihalide. So answer is going to be option number 2. So here you can write answer is option 2 because we are asked which one will not give. The first and the third one will not give. Okay, next is W grams of copper deposited in a copper voltmeter when electric current of 2 ampere is passed for 2 hours. If 1 ampere of current is passed for 4 hours in the same voltmeter, the copper deposited would be. So here we can apply the Faraday's law. So according to that, we all know that the amount of substance that is deposited or liberated at any electrode, it is directly proportional to the amount of electricity passed through it, means the amount of current passed through it. Okay, so here we can do it in a very easy way. Since W gram of copper is deposited, so firstly we can find out the amount of charge. We can find the charge. So amount of substance is directly proportional to the charge, no? So in the first case, 2 ampere is there and 2 hours is there. So it's going to be like 4. And in the second case, 4 hours and 1 ampere. So 1 into 4 is again 4. So if the charge in both the cases is coming equal, so it means equal copper would be deposited. So in first case, W gram is deposited. In the second case also, W gram would be deposited. So yes, the answer is option A. Next is question number 67. A is an allotrope of carbon which is made by heating graphite in electric arc in the presence of inert gases such as helium or argon. It's the only pure form of carbon because they have a smooth structure without having dangling bonds. Cage, and it's a cage-like molecule. So we know that the cage-like molecules are the fullerenes. And they are prepared by heating graphite in electric arc in the presence of inert gases. They don't have dangling bonds. So yes, dangling bonds are there in graphite. Means the bonds are formed, but still there the valency is not complete. We know in graphite the one unpaired electron is there. So in fullerenes there is no such bond. It has a cage-like, soccer-like structure. So yes, the compound A, the element A we are talking about is fullerene. Next is which compound has the maximum dipole moment. So here we are having methyl, fluoride, chloride, bromide and iodide. So we know that yes, fluorine is more electronegative than chlorine, then bromine and then iodine. And dipole moment is it's denoted by mu. It is the product of the charge and the distance between the positive and the negative charge. So amount of charge into distance. So if we know that fluorine is most electronegative, so we might say CH3F has maximum dipole moment. But because of the bond length, now this CF bond is less, it has a less bond length than the carbon and chlorine bond because of high electronegativity of fluorine only. So the bond length is less. So it's not only the charge but the bond length that is also determining the dipole moment. So in this case, the maximum dipole moment would be of methyl chloride. So that is the case and answer is option 2. Next up, which of the following is not the product of dehydration of the given compound? So in dehydration, we know that there is a loss of water molecule and a formation of alkene would happen. So all of these alkenes are given. Now let's see here. First of all, protonation will happen, OH2, and there would be a carbocation that is formed after the loss of water molecule. So here we can see like this. So here at this carbon, carbocation is formed and we have like this. Now see, now the loss of hydrogen can happen in 3 ways. So this is a methyl group, this is a methyl group attached here and there is CH2. So here also one hydrogen is there. Okay. And here also one hydrogen is there. Now you can see the adjacent hydrogens are this one. So this hydrogen can be removed and okay, so here it was like this, no? Just a minute. So it's not CH3 here. Yeah, like here. So one hydrogen is here, one hydrogen is at this carbon, okay, here. And okay, like this. So and the other one is here, means there are 3 hydrogens that can be removed. So by here we have mentioned at A, B, C, and by all of these parts or double bond will be coming at this position if this one hydrogen is removed. Then a double bond will come at this position if this hydrogen is removed, and if this one is removed, a double bond will come at this position. In any of the case, the double bond is not coming in the ring, so means this product is not formed. So the answer is option 2. Alright, so let's move on to question number 70. For the first order reaction, the plot of log K against 1 by T is a straight line. The slope of the line is. So we all know that for first order reaction, log K is equal to log A minus EA upon 2.303 RT. Now let's compare it to the equation of line y is equal to C minus mx. Because here y is log K and x is 1 by T. We are plotting log K and 1 by T, no? So if you compare the values here, so log A is the intercept, like it's C, and minus m value is minus EA upon 2.303 R. Right? So that is going to be the slope in this case, that is EA upon 2.303 R, which is option C. Negative sign means it's a like here you can see the graph. Question number 71. Which are correct statements for diborane? Okay. So let's have a look at the structure of diborane. So diborane mein boron is sp3 hybridized, means it is having 4 hybrid orbitals. Okay, having 1 electron in each of, like in 3 of them only. Alright. So 2 are forming terminal bonds here. Now you know that there are 4 hybrid orbitals. So like other one is having 1 electron and 1 electron. So that electron will be shared and a banana bond is formed. This bond is called 3-center 2-electron bond. So this molecule is not planar, although these terminal hydrogens are in this plane, but these bonds, the bridge bonds that are formed in this case, one is above the plane and one is below the plane. So first statement is correct. Boron is sp3 hybridized. 2 terminal BH bonds for each boron. This is also true. 2 3-center 2-electron bonds are present above and below the plane. Yes, you can see there are 2 3-center 2-electron bonds present. So it means the answer is option number 4, that is all the statements are correct. So next up is question number 72. So we have to find out the intermediate in this reaction. So clearly we can see that we are having toluene and we are having chromyl chloride in the presence of CS2. So this reaction is known as Itard's reaction. This is a naming reaction. So there will be an oxidation of the methyl group, okay, into aldehyde using chromyl chloride. So here the intermediate formed is the fourth one. Yeah, this one. So this intermediate is formed, which is the chromium complex, and on hydrolysis it will give you the aldehyde. So the answer is option 4. Question number 73. The time for a half-life period of a certain reaction is 1 hour. So half-life period of a reaction is given T half, it's 1 hour. When the initial concentration is 2 mole per liter. Initial concentration we can take as A naught, it's 2 mole per liter. How much time it takes the concentration to come from 0.50 to 0.25 if it's a zero order reaction. So first of all, we know that for a zero order reaction, T half is A naught upon 2K, means the initial concentration upon 2K. So from here the value of K could be found out. So put the value, T half is 1, it's 2 upon 2K. So the value of K is coming out to be 1. Now if K is coming out to be 1, now let's put the value. So we know that K is equal to 1 upon T, A naught minus A. So here T we know it's 1. The concentration is coming from 0.50 initial and final is 0.25. So it's coming out to be 0.25. So it means it will take 0.25 hours for this much concentration change. Next is question number 74. Nitrogen forms N2 but phosphorus is converted into P4 from P2. The reason is, now we know that the size of phosphorus is more than nitrogen, okay. So it is having bigger size than nitrogen. So in nitrogen there is a triple bond, means there is pi bonding. Now because of the big size of your phosphorus atom, the p pi bond is not possible. The p pi bonding is weak. So it cannot form in this case. That is why it is converted to P4 where it is having sigma bonds. Because pi bonding is not stable in this case. So yes, the answer is option number 1. Weak p pi bonding is the reason that P2 is not there. Question number 75. Compound X on reaction with ozone followed by zinc and H2O gives formaldehyde and 2-methyl propanol. So the compound X is. Now first of all we need to see what are the products present in this case. So it's 2-methyl propanol and formaldehyde. So we need to find which alkene is there. So we know that here there is ozonolysis happening in this case, right? So if there is ozonolysis happening in this case, we need to see which alkene is formed. So let's see where we can write. Clearly you can see that we are having this group in this case and there is a double bond at this position. So we can make this group isopropyl group. Okay, so this isopropyl group is there. Now there would be another carbon and then there is this double bond O now. So that is CH and double bond CH2. So this will be our alkene because when ozonolysis will happen, so we will get this reaction intermediate CH3, CHO, CH2. And then yes, after hydrolysis, what will happen? So this will break like this and like this. Okay, so in this case you will be getting CH3CH, CH3, CHO, okay, like this, and plus CH2O is there now, so means it's formaldehyde. So that is the case that is happening here. So the reaction or your alkene is 3-methyl but 1-ene. Like here you can see 1, 2, 3, 4. So it's 3-methyl but 1-ene. So answer is option number first. Next question number 76. The boiling point of 0.2 mole per kg solution of X in water is greater than equimolar solution of Y in water. The correct statement is. So X is undergoing dissociation in water and they are equimolar. Equimolar means the molality of X will be equal to molality of solution of Y, which is given 0.2 mole per kg. Okay. Now the boiling point of solution of X is greater than that of the solution of Y. So we know that the relation of elevation and boiling point is means the temperature change, it will be equal to I Kb into M. I is the Ventov factor, Kb is the elevation constant and M is the molality. Now since molality is same, so we can say in this case delta Tb of X would be greater than the delta Tb of Y. Why? Because it's given that the boiling point is greater than for X is greater than that of Y. Now Kb is constant, molality is equal. Okay, we are only left with I, so it means the value of I for X would be more than I for Y. Okay, so it means that X, the solute of X is undergoing dissociation in this case. Okay, so that is going to be the answer, option number 1. Which of the following ions will exhibit color in aqueous solution? So you know that the color is exhibited if there is unpaired electron present. So in scandium 3 positive it's 3d0. In lanthanum 3 positive it's 4f0. Yes, titanium 3 positive 3d1 and lutetium 3 positive 4f14. So in other three cases we can see that there is no unpaired electron. All of them are paired, but yes, in titanium 3 positive there is 3d1. So it would be a colored substance, means this ion will exhibit color in the aqueous solution. Because there would be DD transitions, the color is because of the DD transitions only. So that is the answer. Now question number 78, select the correct sequence of amino acids present in tripeptide. So here you can see the first one here, it's NH3. So the first one is valine, then the second one is serine and the third one is threonine. So valine, serine and threonine, the answer is option A. So for that we need to know the structures of these amino acids, then we can do this question. Question number 79, consider the statements and we need to find out the correct statements. First one, sodium dichromate is less soluble than potassium dichromate. This is true. It is less soluble. Crystals of potassium dichromate. Yes, dichromate ion is giving orange color. So potassium or sodium dichromate, whatever it is, they'll be orange in color. This is also true. Chromates and dichromates are interconvertible depending on the pH. Yes, chromates and dichromates, they can be interconverted depending on the pH. Oxidation state of chromate and dichromate are different. This is wrong because the oxidation state of chromium and chromate and dichromate is +6 in both of them. So that's why it is not correct. So first, second and third are correct. The answer is option 3. Now which of the following will undergo Hofmann's bromamide reaction? So this is our question number 80. Now students, so you all know that in Hofmann bromamide reaction what happens is there is an amide. It reacts with bromine in the presence of a base NaOH or KOH, whatever it is. So it gives the intermediate and after that it gives amide, means the amide is converted to an amide. But the condition is that this reaction is only given by primary amides. Primary amides. So here in this question, here this is not an amide, this is wrong. Alright, so this is a secondary amide, this is also not correct. Yeah, this one, third one is a primary amide, so it will give Hoffman bromamide reaction. The second, fourth one is also a secondary amide, so it will also not give. So yes, the answer is option 3 because it's a primary amide. During the reaction of oxalic acid, potassium chlorate and sulfuric acid, the oxidation number of which of the elements undergoes a maximum change. For that, we need to see the reaction. So here students, we can see the reaction. Alright, so for hydrogen, the state is +1 and it is changing to +4. Then for sulfur, it is changing from +6. Oxidation state of sulfur remains same, +6 to +6. Then let's see for carbon, it's changing from +3 to +4. But for chlorine, we can see that for chlorine, it is changing from +5 to -1. So that is the maximum change that is it is undergoing. So the answer is going to be option number 4. Question number 82. According to Werner's theory, the primary valencies of the central metal atom are. So you know that the primary valency is the one which is the ionizable valency. Means it corresponds to the oxidation state of the metal. Oxidation state of metal. And it will be satisfied by the anions always. Okay, so it will be satisfied by the anions, means the negative ions. So the answer is going to be option number 2. A molecule is said to be chiral. Okay, so students, we all know that chiral means asymmetric. Okay, chiral means asymmetric, and let's see, chiral molecule is the one which is like here. Let's see if this is a carbon atom. So if there are 4 groups attached to carbon atom, so this molecule does not have any center of symmetry. It is not having any plane of symmetry, and cis-trans isomerism, it's not important. The molecule is said to be chiral if it cannot be superimposed on its mirror image, because since it is not symmetrical, so it cannot be superimposed on its mirror images. So that is going to be the answer. It means they are non-superimposable mirror images. Question number 84. Neutral ligands NH3. So NH3 is known as amine, and CO is known as carbonyl, and NO is known as nitrosyl. So the answer is option number 1. So here we just have to name the ligands. This is easy. Next is question number 85. An aqueous pink solution of cobalt 2 chloride changes to deep blue in addition of HCl. Okay, so in this case, students, what happens is that our cobalt 2 chloride, it changes to deep blue solution in excess of HCl because this COH2O6, okay, like this, you can write 2 positive. It is converted to COCl4 2 negative. Alright, next it is now written about the tetrahedral and octahedral. So you know that the crystal field splitting energy for tetrahedral complex is 4/9 times for the octahedral. So yes, it means that the tetrahedral complexes have smaller crystal field splitting than octahedral complex. So fourth one is wrong, third one is correct, and the second one is correct. It is transformed to COCl4 2 negative. So option A first is correct, that is 2 and 3. Next up, electron gain enthalpy of fluorine, chlorine, bromine and iodine. So this is very interesting. So we know that electron gain enthalpy is the enthalpy for converting the neutral atom to an anion. Like whenever an electron is added to a neutral atom, energy released is called the electron gain enthalpy. So we know that all the halogens, since they just require one electron to become stable, they have negative electron gain enthalpies. Okay, and generally when we are moving down the group, the value of electron gain enthalpy becomes less negative, because the size of the atoms increases and the nucleus can, like nuclear charge, the effective nuclear charge also decreases, size of atom increases. So there is less attraction for the incoming electron. So the order should be fluorine, chlorine, like this one, it is decreasing, no, becoming less negative. So fluorine must be having the highest most negative electron gain enthalpy, then chlorine, then bromine, and then iodine. But there is a change here in fluorine and chlorine because the size of fluorine atom is very small. Okay. So the incoming electron, it experiences repulsion because of the small 2p orbital in which the electron is coming. But chlorine atom is having a relatively bigger charge, so the incoming electron does not have that much repulsion. So that is why the enthalpy of chlorine would be highest, electron gain enthalpy, followed by fluorine, then bromine, and then iodine. So there is this change in this case. So the enthalpies are given in this case. So it means for fluorine, it is 333, then there is an increase like this, then there is a decrease. So it's option 3. So that's going to be the answer. Question number 87. Which of the following is an incorrect explanation of atomic radius? So atomic radius changes when the atom is present in different bonded state. Of course, whenever there is different type of bonding, the atomic radius is going to change. The atomic radius are measured by X-ray or spectroscopic methods. Yes, they are classified into covalent and non-metallic. So this is not true because they are classified into covalent radius and metallic radius, not non-metallic. So it means the incorrect statement is the third one that we have to choose. Reagent used for testing ammonia is, so it's K2HgI4, which is known as the Nessler's reagent. It is used for testing ammonia because when it is added into the ammonium solution in the presence of an alkali, it gives a brown color, reddish brown color PPT with ammonia. So yes, alkaline solution of potassium tetrahydromercurate is known as Nessler's reagent. Next question, students. In a laboratory setting, the confirmation of presence of nitrate ions in a solution is indicated by development of colored ring. So what is that ring called? So we know that the presence of nitrate ion is confirmed by a brown ring test. This is a very common test. Brown ring appears at the junction of the two layers. So in the presence of nitrate ions, yes, ferrous sulfate is added, and then we get a complex which gives a brown ring at the junction. So clearly the answer is option 4. Next question number 90. Which of the following bromoalkane is most reactive towards E1 reaction? So we know that the elimination reaction, that is E1 elimination reaction, it takes place by the formation of the carbocation. So more stable the carbocation is, more the your reactant would be reactive toward the E1 elimination. Now in these cases here you can see that when bromide is removed, here we are getting tertiary carbocation, here also tertiary, here also tertiary, here it's secondary. So this option cancels out because tertiary carbocation is the most stable, followed by secondary, then primary. Now all of these are tertiary carbocation, but in the second option you can see that there is a phenyl group attached to it, C6H5 ring is attached to it. So that is why here the positive charge will be stabilized by the phenyl ring because of resonance, and this would be the most stable carbocation and it would be most reactive towards the E1 reaction because of the presence of phenyl ring. So that is the answer. Next up is question number 91. We are having 100 ml of 0.2 molar acetic acid and 100 ml of 0.1 molar NaOH. So they are mixed together. We need to find the pH of the resultant solution. So if I want to find the number of moles, so number of moles will be like 100 into 0.2 for acetic acid and 100 into 0.1 for NaOH. So it's 20 and 10. So they will neutralize each other, but only 10 moles will neutralize. So after the reaction, like finally we will be left with 10 moles of your acid and 10 moles of salt would be formed. So it will be behaving like an acidic buffer solution. So pH would be pK plus log of concentration of salt upon acid. So 10 moles are left. So here we can write it's 10. So 10 upon 10 log 1 would be 0. pK is given 4.7. So the pH of the solution will become 4.7. Because since there are 20 and 10 moles, only 10 moles will be neutralized, 10 moles will be left. Next is your 92nd question. Identify Z in the sequence of the reaction. So there is an alkene given to us, CH3, CH2, CH double bond CH2, and HBr is added in the presence of H2O2. So if H2O2 was not there, it would have followed the Markovnikov addition, but in the presence of a hydrogen peroxide, anti-Markovnikov addition will happen. Okay, so in that case, the CH3, like the HBr will be attaching like this. The bromide will be attached to the one having more number of hydrogen like this. Okay, CH2Br. So this will be the product that will be forming. Now we are adding sodium ethoxide to it. Now the reaction between an alkyl halide and sodium ethoxide to form ether is called Williamson synthesis. So here CH2 twice I can write. Okay. Oh, not twice, thrice, because there are 1, 2, 3 groups. So we can say it's CH2 thrice and followed by O and C2H5 means CH2, CH3 and NABR will be removed. So this is Williamson's ether synthesis that is happening in the second step. So this will be the ether that is formed. Ethyl propyl ether would be formed. Okay. Ethyl and butyl ether will be formed. So that is going to be the answer. Means it's option number 1. Next up is question number 93. Ionization constant of weak acid is given. Concentration of hydrogen ions in 0.02 molar solution is. So we know that the acid will ionize like this. It will give you H plus and A minus. So for weak acid, the concentration would be Ka into C. The constant is given, concentration is given. So we will be solving it and the value will come out to be 8 into 10 to the power minus 6. So that is going to be the answer. Next is we have to match the product form with the reaction of carbonyl compounds. Okay, so carbonyl is this. So the first one is, in this case, first is cyanohydrin. So we know that the carbonyl compounds, they will react with HCN to form cyanohydrin. So it's A for HCN. Then acetals. So acetals are actually a derivatives that are used as the protecting groups. Protecting groups for aldehydes and ketones. So cyclic acetals are formed when your carbonyl carbonate reacts with like in the acid catalyzed reaction with diols like ethylene glycol. So then acetal is being formed. So it means the answer is alcohol for the second one. Schiff's base. So carbonyl compounds react with amines RNH2 to form Schiff's base. And then it's oxime. So when a carbonyl compound, it reacts with hydroxylamine, which is NH2OH, so it forms an oxime. So it's A4, B3, C2 and D1. So answer is option 3rd. Next up, class 95th. Which of the following concentrations of ABC represent the equilibrium concentration for this given reaction? So for this given reaction, the equilibrium constant would be concentration of C raised to power 2 because the coefficient is 2 in this case. Alright, then it's A and then B square. So the value is given 2 in this case. So we can put all these values one by one and we can check where the value is coming out to be 2. from the given options, like putting the options we can do that. And from here the answer is coming out to be 4. So A has to be 2 molar, B has to be 1 molar, and C has to be 2 molar. Then the value of Kc will be 2 per molar. So that's the thing. 96 for a reaction, H is 30 kilojoule per mole and S is 82 joule per Kelvin per mole. So reaction will be spontaneous when? So we know that the reaction is spontaneous when the delta G is less than 0. Delta G is delta H minus T delta S. It should be less than 0. So it means that T delta S should be greater than delta H, and it means that the temperature must be greater than delta H upon delta S. So delta H and delta S values are given to us. We can find the temperature. So it's coming out to be 368.5.8. So in this case, the temperature has to be more than 366 Kelvin. So that would be the answer. Alright. Next is question number 97. An organic compound A on reacting with ammonia gives B, which on heating gives C. C in the presence of KOH and bromine reacts to form amine. So students, in this reaction the final product is an amine, and that is produced when C reacts with KOH in the it reacts with bromine in the presence of KOH, means C has to be a amide. Having same number of carbon atoms means C has to be CH3, CH2, CO, NH2, because this is Hofmann-bromamide degradation where amide reacts with bromine in the presence of KOH to form an amine. So it means C is an amide. Now if we look at how C is formed, so C is formed when A reacts with ammonia and on heating it gives C. So we know that when carboxylic acid it reacts with ammonia, it forms an ammonium salt, and then on heating it will form an amide. So it means our first compound A has to be your CH3, CH2, COOH. Okay, propanoic acid which reacts with ammonia to form ammonium salt, and on heating it gives amide, and on like Hofmann-bromamide degradation it forms amine. Now 98, which one is the wrong statement? Uncertainty principle is delta into delta T is greater than 4H upon pi, H upon 4 pi. This is true, uncertainty principle. Then students, half filled, and we know that yes, half filled and fully filled orbitals have greater stability due to greater symmetry and more balanced rearrangement. Energy of 2s orbital is less than 2p in case of hydrogen. Now we know that hydrogen atom is having only one electron. So the energy will just depend on the values of the principal quantum number, because there are no other electrons to influence the energy levels. So it means that if the value of n is same, all of them will be having same energy. It means 2s and 2p orbital which belong to the n equals to 2 second quantum number, the second shell, they will be having same energy. This is not less, so this is wrong. De Broglie wavelength is lambda is equal to h upon mv. This is true. So it means the incorrect statement is option 3. This is going to be the right answer for 98. Next is, which of the following will form more stable carbocation after the C-Br bond ionization? So we know that the order of stability of carbocations is tertiary, then secondary, then primary. Then we can compare allyl, benzylic carbocations and vinylic. So out of them, the tertiary carbocation will be the most stable. So here we will be getting benzylic carbocation. Here it's your vinylic carbocation, and here it is phenylic carbocation. So they are less stable than here we will be getting tertiary carbocation. Why it is most stable? Because the plus I effect is there of 3 methyl groups, as well as hyperconjugation is there. So there will be 9 hyperconjugative structures because of 9 alpha hydrogens. It would be the most stable. Last question is the 100th one. So by a reversible process that always, so basically we know that in an ideal reversible process, the each step it takes in infinitesimally small manner. infinitesimally slow step is there. Okay, so means the system actually maintains equilibrium at every step. So if it is taking infinitesimally slow and it is a reversible process, so we can say that this process will take infinite time for completion. So that is going to be the answer. The answer is option number 1. So students, I hope all the questions are clear to you. So see you next time. Thank you so much.